Oh yeah, here's the big guy.
Oh, I'm sorry, it's just like we looked at before. It's in color. It's pretty. What's this? Oh, Broca, Wernicke. Cool. Primary, oh, this has lots of numbers on it. So far, we haven't touched on most of these numbers. We're not going to worry about them yet. All right? With the exception of area 4. What do you think area 4 is? What's area 312? There you go. Okay. This is a really nice, I'm sorry, I keep pulling illustrations in from lots of different books to add to what you have, but there are some illustrations that are superior to others. This is a really nice one. It is packed with information. Okay? We've got the central sulcus here. Oh, then we have the precentral gyrus and the precentral gyrus and the postcentral gyrus. Okay? So we have the gyri in there. We've got the prefrontal cortex. Prefrontal cortex is going to become really important as the semester progresses. This has many of the special senses labeled on it. This is one, and I think I said this early on, I would expect you to be able to label this one, all right? You've got all the cranial, well, you've got most of the cranial nerves on here, all right? Which one's missing? Which one? The olfactory, all right? It's not there. But you look at this, and I go, whoa, the big head at the top, that's the thalamus, all right? Between the thalamus and the pons, we have the midbrain. Then we have the pons, we've got the medulla, we've got the pyramids that are sitting here, and we've got a whole bunch of cranial nerves and the peduncles. Who can forget the peduncles? Right? Because it's what it said, don't forget the peduncles. So this isn't too bad. We looked at the spinal cord. Okay. Sympathetic and parasympathetic, but you know, there's a lot of information in here. There's a tremendous amount. Bless you. All right. Do we have disease starting in here? Oh God. So what is this area though? See how swollen it is? It's the cervical enlargement. The lumbar enlargement. These enlargements are really important areas. We have associated with both of these areas all the many nerves that supply plexes. So, the good news, since I kind of got ahead of myself with the autonomic nervous system, the autonomic nervous system in its complexity will be on the next exam. Would you rather have it on this exam?
No.
I mean, I can keep it on this exam. I just think I got ahead. All right? You should know the difference between sympathetic and parasympathetic. So for this exam, know the autonomic nervous system to this level. In other words, where do these nerves come from? You know, which one's parasympathetic, which one's sympathetic, which one's fight or flight, rest and digest. And this figure 2.9 is right out of your textbook. Okay. We looked at the kind of gross structure of the cord. Okay? Once again, early on, I said you should be able to label this. Some of you gave me very nice labeled versions of this, by the way, last week when I asked you to draw something. All right? So, this really doesn't show you any of the pathways or tracks. Where are they in here? They're in the white matter. When you look at it this way, all of a sudden you realize, you know, it makes sense that those somatosensory tracts and the motor tracts are in here. Yeah, because they're all tracts. They're all myelinated axons. So, all right? You should be able to label something like that. once again, if you want to practice, draw that out. You could draw it out just kind of the top view down. You I would not, don't do a three-dimensional drawing unless you're like really artistically superior. First biology class I ever took, we got a list of materials to buy for class. Okay, so we had a dissection kit we needed. And then we needed what was called biology drawing paper, number 3 pencils, number 2 pencils. We were expected to draw when I went to school. So, you know, it's kind of different. Oh, the embryological development. Yes, we've looked at this, all right? We looked at differentiating the 3-vesicle stage from the 5-vesicle stage. 3-vesicle stage, we have a prosencephalon, a mesencephalon, and a rhombencephalon. 5, the prosencephalon becomes the telencephalon, the diencephalon. The rhombencephalon becomes the met and the myeloencephaly. So, a lot going on. You should know, something you should try, all right? Recreate this table from memory. Sit down, draw it out. And then on top of it, we've got all of the ventricles associated with this, the whole ventricular system. We're going to look at that again in just a minute, okay? Here you are. This is you, very young age. Okay, I don't know, it's a drawing of maybe somebody he knew. But, yeah. The development of the neural tube. Development of the neural tube is crazy important. It really is. Failure in this process leads to all of this stuff. All right? We have spina bifida, myelomeningocele, anencephaly, or meningomyelocele. Once again, I have seen, it's 2 different ways here because I've seen it used in both ways. Okay? So, there's a lot happening. You should be able to describe these. Then we transitioned to talking about the meninges, CSF production, a whole bunch of other things. This just happened to be a summary slide from the beginning of one of the lectures. The ventricles. Everything that's here is on the inside of that tube. Okay? We haven't started development. The primary brain vesicles, we're only, I don't know, 10 or 12 days into development where this region starts to pull out and move forward. This region pulls. This is pulling. You should think about that. It's like you take, if you got one of those long straight balloons and barely put some air in it, you could pull it at different parts and see what's happening. As development continues, we're now 10 days later. The prosencephalon, we start to see the ears forming. We start to see the optic nerve and the retina moving out. So a lot is going on. But through this entire process, we have these spaces. They are going to become the ventricular system. The ventricular system in its entirety is the remnant of the inside or the lumen of the neural tube. We okay with that? Once again, this just summarizes that figure from your textbook. But it ties together the ventricles with all of this. And what's happening during those developmental stages? Okay, here you are once again. 1, 2, 3, 4. Oh yeah, this is the five vesicle stage. You know it is because there's a telencephalon. The minute you see the word telencephalon, it's no longer the 3 stage, it's the 5 stage. So that's a good point of reference for you. And that telencephalon is the region that is going to develop the most. It is going to expand. It is going to move. It's going to move forward. It's going to move backwards. It's going to loop around. It's going to move to the side. There's a lot going on. And that's how you're going to end up with that really wonky set of ventricles, especially those lateral ventricles. The lateral ventricles get pulled to the sides. We'll look at that. And at the same time all of this is going on, the development in here, we have flexing happening. And that flexing is what is going to allow the neural tube to pile in under that superior aspect of the neural tube. Okay? So this was the tip of the neural tube, the telencephalon. Ultimately, it wraps itself around all of the other structures. So, yeah.
Yeah, the D one, how many weeks is that?
That's an adult.
Oh.
That's an adult brain.
So means that the baby, the toddler, they don't develop.
Oh, this by adult brain, that brain is very close to what you had when you were born. You're born with an adult brain, more or less. There's not a lot of development that goes on, there's growth that goes on. Everything is more or less in place. There are lots of there are a lot of connections being made. There's a lot of expansion of dendrites and dendrite pruning and a lot going on. But all of that, all of those structures are there already.
So form and then deliver the baby, have that, and then they after they are born and then get bigger.
Yeah, it gets a little bigger. Yep. Be happy. Yeah, a lot of this is just expanding. So, yeah. But all of these basic structures are there at birth. If you were to see a 9-month brain versus a year-old baby, so 9 months in utero versus a postpartum year, one just looks bigger than the other for the most part. This, on the other hand, you know, these stages here are probably all first trimester.
If the baby were born like that, probably can't live.
Like this?
Yeah, probably die.
Yeah. I mean, they would die. So, there's no folding that's happened here in the cortex. This brain is not at all a cognitive brain. This brain can sustain heartbeat, breathing, ultimately, some function. The autonomic nervous system would work, but there'd be no cognition.
It's like an encephalon, right? Like birth without brain.
Oh, the anencephaly?
Yeah.
Anencephaly, this never happens.
Yeah.
This development doesn't happen, so that the brain will be developing from the diencephalon down. The whole telencephalon area would be missing. Yeah. So the ventricular system. We have the lateral ventricles here, this weird lateral ventricle. That weird lateral ventricle, okay? So you have 2 of them. And the reason you have 2 of them, thinking back to those kind of elephant ears forming on the side of the telencephalon. As that pulls out, it's pulling these with it. They're being pulled out. Part of it moves forward, okay? And that's this. You'll notice right here, here's the neural tube coming up, and then it's right here that this gets pulled to one side, the other one gets pulled the other way. This moves forward slightly,